In Sri Lanka, there are several problems in coconut cultivation. Maintenance cost is high, pest diseases, lack of coconut cultivation, shortage of spaces, shortage of labor are the threats we are facing in coconut industry. In addition, coconut leaf diseases also major threat for the coconut cultivation. There are various types of diseases affect into coconut plants. They are leaf diseases, pest diseases and stem diseases. Currently in Sri Lanka, coconut pest and leaf diseases are mainly causes for lack of coconut cultivation. From there, coconut leaf diseases are taking a main place. In there, we can see two coconut leaf diseases. They are leaf spot and leaf blast. You can see there are images for leaf blast and leaf spot. When the diseases attack into coconut plant, it will reduce the harvest and finally coconut plant will die. There are several projects that has been done into coconut leaf diseases identification. So far there are no projects has been done in Sri Lanka or other country to identify coconut leaf diseases. This is the main research gap I have found. There are lots of coconut leaf diseases can be seen in Sri Lanka. So having a project for identify coconut leaf diseases will affect the future of coconut cultivation in Sri Lanka. In addition, existing leaf diseases identification projects show between 80 to 90% accuracy. This project is expected to show more or equal accuracy. The existing systems are divided into two parts and documented in literature review chapter. These are SVM based and ANN or deep learning based projects. None of these projects have been carried out so far to identify leaf diseases, and they are focused on coconut pest diseases. Also, there is no dataset in Internet or Coconut Research Institute in Sri Lanka to carry out this project, and others have to create a new dataset for it. Therefore, main research gap is this project. High-level architecture diagram. High-level architecture is common framework that defines specific system layout using design tools and interfaces. The high-level architecture of the proposed system visually represented in this slide. It uses three-tier architecture model. Using this model, author was able to show a clear distinction for the between the functionality of the proposed system, and it is also divided into three separate layers. The presentation layer is the first and top layer in this concept. Actually, it would be client component. Next, there is logical layer to implement the business logic of the system. Finally, there is the data layer to store data. First layer is the presentation layer. The presentation layer will be a web or mobile application that interact with users within the proposed system. Upload image UI. The user can take a photo of coconut leaf disease and upload it to the application using with this UI. This uploaded image will be sent to the server. Predicted disease UI. Show the predicted result related to the image uploaded by the user in this UI. The disease name and the accuracy percentage will be shown as this result. Solution UI shows the solutions to prevent the control the identified disease. Contact Coconut Research Institute Expert UI. If user wants to know more informations about coconut leaf diseases, user can be contact with Coconut Research Institute domain expert. Next is profile UI. User can add or update his or her personal details in this UI. Then you can go to the second layer. The second layer is the business logic layer. This is the logical layer to implement the business logic of the system. Coconut leaf diseases image classifier. This is the main and core function of the proposed system. The core function is the content of several other functions. These are mentioned in below. The next one, data pre-processing. When collecting data for the dataset, by on the data comes in variety of backgrounds and dimensions, but the data so collected must be pre-processed before training. OpenCV is used for data pre-processing. The next one is create the model. A model was created using CNN to diagnose coconut leaf diseases. Here use Keras open source software library with CNN. Train the model. The generated model was trained to obtain high accuracy for valid data. Predict coconut leaf diseases. The disease must be identified in relation to the image input by the application using the trained model. The final layer is the data layer. This is the data layer of this proposed system. Database. The system database contains the personal information of the people who use the system and the images of coconut leaf diseases that people add to the identifier. This is my project model code. I used Google Colab for build this. In very first, this section shows important libraries and necessary packages. Then this section shows mount Google Drive to Google Colab. In this section also show added some important libraries, and this section is for resize the all images to one size, and this section is for set paths for training, validation and testing folders. These three code lines used for xtrain, xtest and for xval. In here resizing image to 200 to 24 and 224. Since we need a fixed common size for all images in the dataset, and appending the image and the label into the list. This code is used for C shapes, and this code is for normalization. And this code is importing image data generator. This section is used for add rescaling option by using image data generator, and next giving path for training, testing and validation dataset using flow from directory. I choose batch size as 32 and class mode as pass. After executing this code, we can see how many images and how many classes are there with train, test and validation data paths. Next line shows 0, 1 and 2 for labeling images. This is w1673758 model. There are some arguments in this function: input shape, optional shape, tuple, only to be specified if include top is false. Otherwise, input shape has to be image size 224, 224 and 3. Weight is image net or the path to the weights file to be loaded. In this section, flatten this out and apply 3 dense layers with softmax activation. This code is for model summary. You can see these are the layers and total parameters are here. This section shows compile of the model. We will take loss as sparse categorical cross entropy and optimizer is Adam and metrics as accuracy. We can change this loss and optimizer. This is early stopping function. This section is used for early stopping function. When the model is training, it will be automatically stopped with less number of epochs with high accuracy, not going with all epochs. This code is model fit code. In here I have added a list of function and the epochs are 100, batch size as 32. When you run this code, you can see validation loss and well accuracy as 85%. The early stop is working here. You can see the early stop. There are 100 epochs, but within 8 it will be automatically stopped. This one is for show the graph of the model, drain loss and validation loss. This is train accuracy and validation accuracy. Here we can see the model accuracy by model evaluate. 51% accuracy here. They also can we can see the accuracy of the model phase 51. And here we can see classification report, precision recall, F1 score and support. This one is for confusion matrix. You can see the result in here. In here we can see the output of dataset by giving path to leaf spot, and if the prediction is 0, the output is healthy, and prediction is 1, the output is leaf blast. If the prediction is 2, the output is leaf spot, else it prints normal. I have given the path for the leaf spot and then execute the code. Then the result is here. And finally, final model is saved as leaf model.h5. This is the H5 file. This is a proposed system web application for coconut leaf disease identification system. In here I have added a small slideshow with 2 images, and I have added some small description about coconut cultivation in Sri Lanka. Then I have added some images about of leaf diseases. In this section we can choose the image and can see the result. These are the preventing methods for the diseases. Then I'm going to here and click this choose file button, and I'm going to add an image. Test data I have categorized as 3 folders. Then I'm going to add a leaf spot image. Then I have choose this one and open. You can see the image name here. Then I am going to click submit button. Then you can see the result with image. Then I'm going to add another image. We can choose leaf blast. I'm going to add this one. Then click open. Image name is appear here, and I'm going to click submit button again. There's the image and output is leaf blast. Then I'm going to add another image. This data I have already added leaf blast and leaf spot, so I'm going to now add healthy image. I have choose this one, open. Image name is appear here. I'm going to click submit. Yeah, the image is here and the output is as healthy. And I'm going to add another image, leaf spot. I have added this one. I'm going to we'll try this one, open, submit, leaf spot.